Industry 4.0. So we cover what is the Industry 4.0 means, and then where it comes from. One of the key words is outsourcing of especially parts of the large product. And then personalized production is another characteristic of Industry 4.0. All right. There are people are saying that there are four phases of industrialization of industry revolution. One was in 18th century when the water and steam power was used to run mechanical production facility, especially for clothing industry. Industry 2.0 is about beginning of 20th century, so about 100 years ago. They start to use electrical power to making a mass production. One key case was Ford company of conveyor belt. Industry 3.0 is in 70s, 1970s, say about 50 years ago. So humans start to use electronics and computers to automate production. Now we are saying Industry 4.0 is using cyber-physical system and another level of automation. So same idea with a little bit different viewpoint. The content is almost same. So mechanical weaving room and water and steam power is same. 2.0 was production line, mass production, electrical energy. 3.0 is a programmable logic controller, PLC, and electronics and IT for automation. Today is still is evolving. Today's technology is evolving, but cyber physical system or CPS, and then virtual object and processes via information network or smartphone. So in early days of industrial revolution, it started with the agricultural revolution. They use a technical innovation, something like a planter, harvester, and thresher. So it's a mechanical devices are used, and also chemical use of fertilizers, and then also cattle are breeded. The meat consumption is increasing. Also, grains are produced more than before by using technology. So because of the agricultural revolution, the result, it comes with the food surplus, diet is improved, so that health is improved. The death rate is lower down, so that the population, human population is rapidly increased. So the surplus of population from the farmland gathered into cities. So cities are evolving because of the more than enough food coming from agricultural revolution. So once again, similar picture with the industrial revolution. There is a surplus of population because of food. So there was a population boom in the early 19th century, So agriculture as a food, and so that workers in farmland is surplus because of population increase and technology level. So extra workers started to change into another job rather than farmers. So they come to the cities and also to the factories. This one is about the book titled of Being Digital. It was also written more than 25 years ago by a professor in MIT. So that digital means digital revolution. Still, we are in the process of a digital revolution these days. So food or car, which one is more important for living? And which one is more expensive? Same logic goes to a car or painting by Picasso, painting. Which one is more expensive or which one is more indispensable? So that kind of changes coming from food and car and Picasso painting is the reason for surplus of something. Surplus of food, surplus of car, and materials. So surplus induces changes in society. He's saying the Nicolas Negroponte. And that is coming because of the technology improvement and resources not enough. So even though there is a starving children around the world, but also there is a lot of food is abandoned as a garbage. So, but the sharing of food or material, if I share my food, my portion will be smaller, but information, something like a book or Bible can be shared without shortage. The value can be doubled. But one disadvantage is a price fluctuation of stocks or Picasso paintings bigger than before because of the information speed of information exchange. But these kinds of changes are coming from digital innovations or using computer or telephone communication. So same picture again, industrial revolution, 19th century, 20th century, we are now in 21st century. And once again, and the fourth revolution, they are saying cyber physical system or CPS, but also we are talking about big data and artificial intelligence and smartphone. Now let's go into the another characteristic of Industry 4.0 was outsourcing. So in 100 years ago, when the Ford company developed a conveyor belt for mass production, at that time, the famous car name was T1. And they produced T1 car as fast as much as possible. So Rouge factory of Ford at the time in Detroit City, Detroit of Michigan State of United States. That was the world's biggest factory at the time. 100,000 people work at one site, and they produce all the components of a car. At that time, the T1 car is very simple than cars of today. So that number of components are probably much smaller, but anyway, the Rouge company factory, they produce all the components of the car at the site, one factory. So I'm saying that there is no outsourcing of components. So that the factory, Rouge factory, has their own steel mill, also glass factory, and also tire is also produced at that site. So we call this is a mass production area, start of mass production, comparing to new trend as mass customization. So mass production is trying to make same product as fast as possible. But mass customization means it is something like a tailor-made production. So this is a picture coming from Ford Rouge plant in about 100 years ago. It looks like a factory or steel mill, something with chimneys, large chimneys. And also the level of automation level is low at the time. So the assembly line, you see every components are assembled at site with many people at the assembly line. But right hand side, this is a final assembly line of Hyundai Motors company. And there is very few people are working at this conveyor belt or assembly sequence. So the number of automation, level of automation is different. So that oversupply or surplus, the data increase over internet is doubles every 100 days over the world. And then the food of production is enough. And because of the agriculture revolution, and then cars are coming with the Ford company or mass production. Nowadays, we are focusing on information or data oversupply. So data is more than enough around the internet. But in each case, the surplus induces changes in society. So what can be the society in the future where we are experiencing oversupply of information? Guess what? And in old days, probably this one is coming from Korean War area about 80 years ago. The food was not enough, so that it is something like a supplier market instead of a customer market. Nowadays, surplus of supply, the force is coming back to the customers. So we are saying the customer is king. And now I'll try to explain about what is personalized production. There are so many competing companies or factories, say something like automotive industry. Korea has Hyundai, Kia company. Japan has Toyota, other more, Nissan, and something more, and Volkswagen and BMW in Germany. So, and also China is coming, produce more and more cars, so that there is a around the world it can be overcapacity, oversupply, so that in old days, 100 years ago, the supply has the power because the supply is not enough. As I showed you in this picture, the supply has the more power than customer. And nowadays, because of the oversupply, we are seeing in market, we are seeing the buyer has the more power than supplier. So we call this is a customer is king. So in old days, mass production is needed because there is not enough supply. But nowadays changed so that we need to have a tailor-made production and the mass customization or personalized production. In this way, we need to have a technology like AI or deep learning. So this is a paradigm shift and also market and society changes. This picture is coming from a book. So in horizontal axis, we're saying that product variety, and vertical axis saying the volume, the number of production. So at the beginning in 19th century, we see that there is a craft production. So it is tailor-made of shoes and or clothes. Every item was handcrafted by order one by one. But because of the Ford factory of conveyor belt, we started with a mass production so that the product volume is increased and then product variety is decreased. So same product of T1 car is produced much more, many same car. Now, because of this technology development, we have an oversupply so that customer or market trend is changed to customer has more power. So we need to have a mass customization or personalized production nowadays. So returning back to the old days. So paradigm transition over time. So in old days, we had a craft production in which each product is designed and made for a particular customer. So it is market of one, so tailor-made. And mass production, a few models, less number of models are made because there will be always enough buyers because supply is not enough. And number three, mass customization, where the customers select a product from a list of available options. So because supply is enough, oversupply, so the customer can select from based on their taste. And even more coming to the personalized production. Okay. And then customer role in all paradigms. So in nowadays, personalized production, customer is more involved in design of the product rather than in old days where they have just choose from the market. And the Speed Factory of Adidas was famous. They trying to starting from tailor-made shoes. Now they are changing to the shop where the robots are, and also shoe is 3D printing, 3D printing, and then the weaving is done by robots, so that tailor-made shoes is made within several hours after measuring the foot size. But they call this is a speed factory about. And then the shape of the store is changing like this one with several robots can make the shoes in several hours. So we call this is a personalized production or tailor-made. Now this one is price fluctuation in shipbuilding. I'm trying to explain what is the meaning of Industry 4.0 in shipbuilding and naval architecture. So bulk carrier, we already see what is the bulk carrier and what is the oil tanker. And so fluctuation between 1976 up to 2000. So it is about a period of 25 years. And the fluctuation, price fluctuation of the old or 5 years old ship, the maximum and minimum, and there is some types, different types like the VLCC and Suezmax and Aframax. That is a type of oil tankers. Also, bulk carrier has different types. But anyway, the fluctuation is 7 times within 25 years. And oil tanker is much higher. So 14 times of fluctuation. So this is very rough and wild market. Even though the product is very big and the big money is needed to buy and sell the ship. So there's one video when showing what is Industry 4.0. Let's see the video and then can switch to the second lecture.
A vision of tomorrow's manufacturing.
Let me
Product.
see whether I checked the sound option. Oh, yes, I did. Okay.
Finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first Simatic. Production became increasingly based on computer-assisted control. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed, which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber Physical Systems. Das heißt, Sie haben autokrate selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen und dadurch letzten Endes Produktion optimieren.
Ja, die Vision sieht so aus, dass wir ein Internet quasi hinunterziehen bis auf die unterste Ebene. Das heißt, jeder Sensor, jeder Aktor wäre damit quasi ein Teilnehmer eines Internet der Dinge. Jedes Gerät hat damit eine eigene IP-Adresse, ist damit adressierbar in diesem Netzwerk.
For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes, because in the future, product life cycles will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start.
Wir haben bereits in den 90er Jahren mit Totally Integrated Automation entsprechend ein Setup gewählt, wo unsere Produkte und Systeme sehr gut miteinander kommunizieren können.
At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the Internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can enhance PLCs to use simulation to calculate how much to pre-cool a building, with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We've prototyped capabilities in a PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
Right. Okay, that's the end of my slide set. Well, there's a little bit more, but time is enough. Any question?